Hello everyone, and welcome to another episode of TD 101. In this episode, I will show you how to draw octagons. Firstly, when given the length of one side, and secondly, when given the length of its across flats. Stay tuned. Okay, so we're going to start off with constructing an octagon given the length of one side. Now the length that I'm going to use today will be 30 millimeters. So I'm going to proceed to firstly draw a baseline for my octagon. I'm going to indicate a point A, then a point B. But before indicating point B, I have to measure the distance. The distance, all right, let's change that to 40 millimeters. So from A to B is 40 millimeters. So I have that. Now, as we all should know by now, an octagon consists of internal angles that all measure 135 millimeters. So we can either construct these angles or we can use our 45-degree set square to get these angles. Now, let me proceed. So at point B, I'm going to turn the set square in such a manner that it allows me to construct a 135-degree angle. I'm going to turn the set square in such a manner that at point A, I also have a 135 degree angle. Now, in continuing this octagon, I'm going to open the compass, the distance from point A to B, which should be 40 millimeters. So after doing that, I'm going to swing an arc from point B to cut the line that I've just drawn, and from point A also to cut the line that I've just drawn. Right? There are 8 vertices on an octagon, and I'm labeling it in an anti-clockwise manner. So this will be point A, point B. The new point that I have will be point C. This point, D, E, F, G, H. Let me label it ahead of time. At point C and point H, you're going to take your T-square and the set square to draw vertical lines. So now these vertical lines, you will also take your compass rather, at the same 40 millimeter radius. You're going to place the compass point at C, swing another arc, and at H to swing another arc. Once you have done that, you're going to label 2 new points. So this is now point D and point G. Then you have 2 more points to get. You're going to take your set square once more, position it in such a way that you're getting your angles. So at point G, I'm going to draw a 45-degree line, and at point D, a 45-degree line. Now once I've done this, I'm going to take my compass for the final time, and I'm going to swing an arc, putting it at D, cutting the line that is formed, putting it at G, the compass point, cutting the line that is formed. Right? Now you have line point E and point F. Now once I have all my points, it should be 8 points, I'm going to brighten the points. So from E to F, E to B, those are horizontal lines. So I use my T-square to brighten those to ensure that they are horizontal. Then I'm going to brighten the vertical lines. You can use your 3060 set square to brighten the horizontal lines and the vertical lines rather. Please ensure for this operation you use your 45-degree set square only. 45-degree set square only. Because angles in an octagon, internal angles, correspond with the set square. And there you have it. I have successfully drawn an octagon, given that the length of one of its sides is 40 millimeters. And this is a regular octagon. So AB is equal to 40 millimeters. Now let's proceed to the octagon given the length of its across flats. Now for this exercise, I'm going to use a radius of 45 millimeters, which would mean that the across flats distance would be 90 millimeters. So let me do that ahead of time and let me write what we are about to do. So across flats will be equal to 90 millimeters. So in order to draw a circle consisting of a diameter of 90 millimeters, you have to open your compass to 45 millimeters, which is half of the diameter. In other words, the radius. So I'm going to open my compass to 45 millimeters. And I'm going to draw a circle in construction lines. And please note, the measurement I'm referring to is the distance, the perpendicular distance between the opposite sides. So this side is directly opposite to this, and the distance between these sides, is considered to be the across flats, similar to here. Perpendicular distance meaning this distance, 90 degrees, it forms a 90 degrees with this line and this line. Alright, so now that I've drawn the across flats circle, and remember when we were drawing using the across flats method, the circle is normally inscribed in the shape. So we're going to take our T-square firstly and draw a line that is tangential to the base, meaning it's just touching the base. It's not going inside, it's just touching the base of the circle and at the top of the circle. Right? We're going to then take our set square to draw vertical lines doing the same to the left and to the right of the shape of the circle, just touching. Then the next thing we're going to do is to position our set square in such a way that we have tangents touching at the top right, top left, bottom right, and bottom left corner of the circle. Well, a circle don't have any corner, but at those points, remember you're using your 45-degree set square. Ensure that it's just touching the circle. You should get something like this for here, and something like this for here. Over here, same thing, just touching the circle. It's not going inside the circle. There's no space between the line and the circle. So these lines are referred to as tangent lines. So once you have this, you can now simply brighten these lines where they intersect each other. So I'm using my T-square once again to brighten the horizontal lines. I'm pairing my T-square with my set square in the upright position to brighten these lines. Please observe where I'm brightening. The outlines should not overlap. They should just meet. And I'm going to use the set square in its correct position to brighten the other lines. Now we have 2 more lines to brighten. And you can go ahead and label if you wish. Point A, point B, point C, D, E, F, G, and H. Now when doing this method, we don't definitely know the length of one side unless we measure it. The length of one side here seems to be 38 millimeters. So there you have it. I hope you guys were paying attention keenly. So this here is the length, is an octagon given the length of one side, meaning AB. So the length of AB is also equivalent to the length of BC and DCD, etc. And we have also looked at drawing an octagon given the length of its across flats, meaning the length from one side to another, not from one vertex to another, from one side, the perpendicular distance between. And in doing so, we used an inscribed circle that is equivalent in diameter to that distance, the across flats. So I hope you grasped what was taught. Please like, share, and subscribe, and have a good day.